Let's check the linearity of the differential equation expressed in this manner. The quantity y squared minus 1 times dx plus x dy equal to 0. To determine whether it's linear, we need to anchor it on whether which variable we're going to pick, because here there's no clear identification as to which is the independent and dependent variable. It could go sideways. It could be the dependent is x, independent is y, or the dependent is y and the independent is x. So we are going to attack this in two different ways. But of course, when we talk about linearity, it should follow this certain general form. You have a sub n times x. By the way, if this is in with respect to x, okay, you will have the nth order derivative of y in terms of x plus the constant a sub n minus 1, still x, and you will have here the nth minus 1 order derivative of y with respect to x, it's minus 1, plus dot 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 plus a sub 1 still times x, and you will have here the first order derivative of y and in terms with respect to x plus a sub 0 x and then your y equal to g of x. Take note here that all orders of derivative of our dependent variable, which in this case y, with respect to x, including this y variable here, is actually with a power of 1. Because if it's not, automatically it's nonlinear. And it's equal to a function g of x, whatever that function here, it should only contain a variable of x. So let's start here. Of course, this form is for, in the variable y, where y is our our dependent variable, by the way, in y. So we're going to look into this manner here, and if it's in x, so we're going to reverse all our variables. So if this would be the case, if it's in y, and our given equation here is y squared minus 1 dx plus x dy equal to 0, and we're looking for y as our dependent variable, we're going to divide all terms by dx. Okay, so divide this by dx, so that our second expression will be x, and you have here your first order derivative of y with respect to x, which will follow this form here, and it's really telling us that y is our dependent and x will be our independent variable. So for our first, it will be cancelled. The dx will be cancelled. We have y squared minus 1. Of course, 0 divided by dx is still 0 itself. So let's structure this in a form where it would follow this idea here. So the y variable, y squared, will be retained on the left hand side, and the rest will be go to the other side as well. So arranging this, we have x, the first order derivative of y in terms with respect to x. So you have here plus y squared is equal to positive 1 as we move 1 on the other side. This is a constant function. That's not any variable. So it fits the idea of g sub x, a function of x. However, this here tells us just for this term alone, y squared, this is automatically non-linear in y, because our linearity talks about, looking into this form here, our y, as mentioned earlier, together with all the derivatives of y, order of derivatives of y, should be with exponent 1. And since we have here y squared, okay, it has y squared here, so it doesn't fall into that criteria. Now, if you would like to, you could divide all terms by y. So you will have here x over y, dy over dx, okay, plus y here is equal to 1 over y. But this still violates the idea, because if it's g of x here, we don't want to see a variable of y here on our right hand side, and this also be problematic because it should be in this form here, x, and you have here y. So again, this is non-linear in y. Now let's try if it's still non-linear, or maybe it's linear in x. So as mentioned earlier, all the variables here will be what they call this one, interchange. So this would be y, this is x over y, x over y, and this would be our our form here would be g of y earlier, but let's do it like that. So our original form is y squared minus 1 dx plus x dy equal to 0. So if it's in terms of x, meaning our x is our dependent variable, so we will be dividing all terms by dy. Okay, so you will have here y squared minus 1, and you will have dx over dy. Okay, just like that. And you will have here plus x is equal to 0, as this is still possible to be used. Now, we would like to have a form in this manner. Okay, so still we already have dy over dx, but this is dx over dy, and this is our x here. What we need to do next is, then let's try to divide all terms here by the quantity of y squared minus 1. So you will have here just dx over dy plus x over, you have y squared minus 1 equal to 0. Is this linear or not? The answer here will be determined by the next few steps, as we can rewrite this as plus 1 over y squared minus 1 quantity times x equal to 0. This would be a certain function, any function that you would like to, but this doesn't violate the idea, because looking at here, we will need to have our, this is our dependent variable for this form, so it should be x in that manner earlier. Our x is still with the power of 1. No matter what the value of this expression here, whatever with for any value of y, it will not change the exponent of x here. The same thing, our first order derivative of x in terms with respect to y rather is also with the exponent of 1. This in turn could tell us that this is linear in x. Okay? Earlier, this expression is non-linear in y, but here it's linear in x. Because what makes it non-linear earlier? Because of the presence of our exponent here, y squared, which actually violates this condition for linearity of ordinary differential equation. So for this video, for this item, the expression or the equation is non-linear in y, but it's linear in x. Thank you very much for watching.